Hello everyone. I hope you all are doing well. Welcome back to our AWS AI Engineer Essential series. My name is Dheeraj Choudhary, and today we are diving into S3 for artificial intelligence and machine learning workloads. So S3 isn't just a storage, it's the foundation of your entire machine learning pipeline. So let's understand this and get started. So let's start by understanding what Amazon S3 actually is. So S3 stands for Simple Storage Service. S3 is an object storage solution where you can store literally any type of files like images, videos, CSV files, text document, trained machine learning models, whatever you need. There is no restriction on file types. Then you can start small with a few megabytes and scale up to petabytes of data without any configuration changes or worrying about running out of space. S3 grows automatically based on your needs. Amazon guarantees 99.10 times 9, that is 11 times 9s. That's the 11 nines durability. This means if you store 10 million objects in S3, you might lose one object every 10,000 years. Your data is incredibly safe and protected against loss or corruption. There is no upfront cost or minimum fee. You pay for the actual storage you use per gigabyte per month and for data you transfer out to internet. So data transfer in S3 is free. Now let's understand why S3 is particularly perfect for artificial intelligence and machine learning workloads. AI models needs huge amount of data to train effectively. When building an image classification model, you might need 100,000 images or more. For NLP, that is natural language processing task, you could have terabytes of text data. S3 handles this massive scale effortlessly without any storage limits. When you use SageMaker to train model, it can directly read your training data from S3 buckets. You don't need to download files locally, move them around, or write data transfer scripts. SageMaker just points to your S3 bucket and automatically reads the data during training. In real machine learning projects, your data constantly evolves. You clean it and add new samples or fix labeling errors into your data. So S3 versioning tracks every change. So if the model performance suddenly drops, you can compare the current data with the previous versions to identify what actually changed. When training deep learning models, your GPU needs constant data flow to stay productive. S3 provides high-speed data access, ensuring training jobs aren't the bottleneck for slow data reads. This means faster training and lower compute cost. Before we get hands-on, let's understand three fundamental concepts in S3. A bucket is your top level container in S3. Think of it as the main folder that holds everything. What's critical to know is the bucket names must be globally unique across all of your AWS account. Not all of the AWS, not specifically for your account. If someone else in any other account already has a specific name, for example, if I say if someone is have taken a bucket name named my data, then you cannot use the same name because it has already been used by someone else. An object is an file you store in the S3 bucket that I just discussed is your top level. So first we create bucket, then inside bucket comes objects. So it could be a JPEG file, a CSV dataset, a video file, or a trained machine learning model too. So S3 treats all files as object regardless of their type. The key is the unique identifier or full path for each object within the bucket. It's like the complete address of your file, including any folder structure that you have created. So let's look at an example and understand what the unique key identifier path is meant to be. So over here, the S3 at the start indicates it's an S3 location. Then my bucket, ML bucket is the bucket name, our layer 1. Then dataset train is the path in which we are having our file, and inside this train you can have multiple JPG. So right now it is just pointing to one, it can have multiple JPGs. Now, organization is absolutely critical for machine learning projects in S3, especially when working with teams. Let me show you a best practice structure. Always keep your original unmodified data in a dataset named raw folder. This is your source of truth that never gets touched. Then create a separate dataset train and separate dataset for test folders for your split datasets that you have created. This will create separation, prevents accidental mixing of training and your test data, which would invalidate your model evaluation. Now store all your trained model artifacts into models folder. These are the files SageMaker generates after training completes. Use a separate log folder for training logs and metrics and have dedicated locations for outputs, keeping everything well organized. So looking at this example structure I just spoke about, you can start by this structure in which first I am saying dataset raw. I said you right, keep raw separate, process separate, and split datasets separate. So split dataset means test and train. That is what split dataset is. So I am having raw for original data, then train and test for your splits, then model for the trained artifacts which are being generated by SageMaker model training, and then comes logs. These are nothing but the logs for the model training that I am running. So this is how you can organize your data effectively, and it is very easy to understand. So usually the first one, that is a raw data set, we don't touch it, but the other ones comes into picture while we start training the job. So that is how you can go ahead and do the structure. Now let's talk about one of S3's most powerful feature of machine learning, that is versioning. So when versioning is enabled, S3 will automatically save every version of a file whenever you modify or replace it. Like uploading training. Suppose if I upload training dot csv. So I am uploading this today. Suppose I am uploading it on Monday. And I am going to update that again on Saturday. So S3 is going to keep both the version. So this is going to be my older version. So I can say that this is version 1. This is going to be version 2. And both are going to be having their own unique IDs. So it is not going to overwrite. So on Saturday, when I'm again going to go ahead and push training.csv after making some changes, it is not going to go ahead and overwrite this file. So instead of overwriting, it will create another version. See, so instead of me overwriting this, we created a new version, and this new version, when we create, it will have a unique ID based on which you can differentiate that what exactly has been changed. So the recent changes based on the versioning. Now, if you someone accidentally delete an important data set or overwrites it with wrong data, previous versions are still safe, stored in your S3 bucket. So nothing is truly lost, giving you complete safety net for your valuable training data. With a simple click in the S3 console, you can restore any previous version of your file, which is incredibly useful when you need to roll back to an earlier version of your dataset after discovering there is an issue. In machine learning projects, data constantly changes. You add sample, fix labels, apply processing steps. So versioning gives you a complete history of all the changes which has been done. So you can always trace which exact data version was used to train any specific model. This is critical for reproducibility. Now security is also very crucial when storing machine learning data. So let's understand how control access in S3 helps us over here. You can create a JSON bucket policy that specifies who can read, write, or delete objects in your bucket. These policies are attached at the bucket level, and it is going to give you fine-grained control over permissions for different users or services. Remember the IAM role we created in our previous video. That's how SageMaker gets permission to read your training data from S3 and write model outputs back to the models folder that I just showed you. So services like SageMaker user roles with temporary credentials, not hard-coded password, is much more secure. S3 can automatically encrypt all your data when it's stored, adding an extra layer of security. So this is especially important for sensitive datasets like medical images, financial record, or personally identifiable information. By default, S3 is going to block all the public access to your buckets. So always keep this enabled for machine learning projects to ensure your training data and proprietary models aren't accidentally exposed to the internet. So this is critical security settings that you should take care of. Now let's do some hands-on and create a S3 bucket for our machine learning uh, project that we would be doing with SageMaker. So what I'm going to do is first I'm going to go to S3 console, create a bucket, name it machine learning project data and our channel name, and choose our specific region, and I'm going to create the bucket. So for that, I will jump to our console. Over here, I am going to search for S3. It has shown the S3. I will open S3. Over here, I will click on create bucket. So once I create bucket, this is the region auto selected. If you want, you can change it, but I have taken US East Virginia. Then over here, what name we are going to give? We are going to give the name as ml-project-demo. That is our bucket name. So if you have any existing bucket and you want to copy the details from that bucket, you can choose that bucket. So you can copy the settings from then that existing bucket. Now object ownership, we will see it later. So I will keep it disabled for now. By default, we will keep public access setting for this as enabled. Now our second step is going to be go ahead. I have kept the bucket versioning disabled for now. I was thinking of enabling it later so that I can show you, but what I can do is even I can enable it now, and then I will go ahead and create the bucket with the rest of the settings as it is. Create bucket. So our bucket, okay, so the specified bucket name is already taken. As I said, it should be unique. So I will say demo Dheeraj tech insight. That's a good error. So you came to know that it has to be unique. Now I will click on create bucket, and this is going to go ahead and create our bucket. What's next? Next, we are going to go ahead and create this kind of structure. Now for creating this kind of structure, what I'm going to do is I am just going to create this specific folder for now, and the remaining folder which we would require for our SageMaker model training, you have to do that as part of this tutorial. So make sure that these all you will do create by your own as part of the homework. Now let's go ahead and create our folders. For doing that, jump to the console, come inside the S3 bucket that we have created, click on create folder. Once you click on create folder, so first we have to create dataset. So I will say dataset, it is going to create it. Then inside dataset, I would like to create another folder that is going to be raw. I will just write raw and create. And now my folder structure has been created successfully. So once the folder has been created successfully, the next step for us is going to be to upload a dataset. So I have one dataset. So what I'm going to do is I'm going to go ahead and click go inside raw, and inside raw I will say upload. So once I'm in upload, you can add, it will add folder from here. So it will search in your local directories, but I already have that file available. So what I am going to do is I am going to go add and drag and drop. So I have New York dataset file. So I have just gone ahead and dragged and drop. So you can see this file has been added over here. Now I will just say upload. And that is how your file has been uploaded successfully. Then enable versioning. So if you have not yet enabled versioning, I have done it at the start of the bucket creation. So I told you that I am enabling at that time only, but I wanted to enable right now so I can show you versioning. But if you have not yet enabled till now, what you will have to do is close this, go back over here, click on properties, and you will have bucket versioning option over here edit that and enable it. So once the versioning is enabled, now it's time for us to check if the versioning is really working. So what I will do, I will upload the same file again with some modifications, and then I'm going to go ahead and upload it once again. So I will show you that it is not going to overwrite our existing file. Instead, it is going to go ahead and create a new version out of it. So for that, what I would be doing is I will go ahead and show you what exactly this file contains. Let me open it. So I have my CSV open. So this is one of the data sets. So what we can do is, let's go ahead and delete the first few rows, or I will delete the last few rows. I can do that. So I will delete this row. Okay, and I'm going to save the changes. Now the changes have been saved. I will close this CSV file and I will again say upload. And while uploading, I am going to go ahead and drag and drop the same file over here. Now I will say upload and you will see that it will create a new version out of it. Now you can see it has been uploaded successfully. So if I go back over here, click on this, now we are inside that specific file, that is we are trying to access the object. If I click on versions, you can see two versions has been created. So the previous version was the first time I uploaded, and the second version is the current version, that is the file with new changes. So if I am going to fetch something, it is going to give me the current version. And this, as soon as you keep on adding more, it is going to show you the tree structure over here, that which is the current and which are the previous ones. And that is how versioning works in real time. So one thing you should make sure that if you go to your bucket, there are permissions. So over here right now, it has block public access, which you will do in production for sure. But you can also provide further permissions. So for that, what you can do, you can add a bucket policy. So you can click on edit, add a bucket policy over here, and provide specific permissions for the roles. Suppose we have created one role in our previous video for SageMaker. So we can create a bucket and only give access to that specific role, so it can go ahead and access our bucket folders that we have created. Now, let's understand the S3 cost. So storage cost about 0.023, which keeps on changing. So your work is to always check the official documentation to see if it is the same or it has changed. So if you store 100 GB of training data, that's roughly 2.30 per month. And this is very affordable considering the durability and availability that you're going to get. Then request costs are incredibly cheap. So around 0.0004 per 1000 get request. So even if your training job reads 5 million of times during training, the request costs are minimal compared to your compute cost. Now data transfer out to the internet has charges, but data transfer into the S3 is always free. Remember that. Incoming is free, outgoing is not free. This means uploading your datasets from your laptop or data sources is going to cost you nothing, but downloading the large amount of your data to your local machine is going to incur you a transfer fee. So the AWS Free Tier gives 5 GB of storage and 20,000 GET requests per month free for your 12 months. So this is perfect for learning S3 and running small experimentation project without spending any money. Let me share some pro tips that will help you as you scale as a machine learning engineer where you're going to run your projects on S3. Decide on a standard for bucket names, folder structures, and file names across all the projects. For example, always prefix bucket names with your team name or project code. This makes it easy to find resources months later and prevent confusion when you have dozens of buckets. So enable versioning on all the machine learning buckets from day one. The way I enabled that while creating the bucket itself, not after you go ahead and create the bucket. So the small extra storage cost is worth the insurance, and you will thank yourself when you need to recover an accidental delete dataset or investigate why a model performance has changed. So S3 has cheaper storage classes like Glacier for data you can rarely access. So set automatic lifecycle policies to move your old training data or your previous model versions to Glacier after 90 days, and this can reduce your storage cost by 80% for archived data. Add tags to your buckets like project name, team name, and the environment type like developer, staging, or production. This helps you track cost per project and understand exactly where your S3 spending is going when you review your monthly AWS bill. And that wraps today's tutorial for S3 for AI on AWS Cloud. If you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming tutorials. Thanks for watching, and I will see you in the next video.